Hello everyone! In this video, I would like to invite you for a conversation about the buck and the boost converters, and to do so I'm bringing 3 exercises. Let's go to them. I'm gonna read the first exercise. What is the output current of an ideal buck converter whose input voltage is 100 volts, input current is 5 amperes, and output voltage is 25 volts? Okay, my friends, this is the exercise. Let's go to the solution. If the converter is ideal, then its efficiency is 100%. That is what does it mean? It means that PS is equal to PO. If the efficiency is 100%, the input power is equal to the output power. Whenever this happens, we can say that Vs times Is is equal to Vo times Io. We want to calculate the output current. Io is going to be equal to Vs times Is divided by Vo. Now we can use the data that the exercise provided. (100 volts times 5 amperes divided by 25 volts, which is equal to 20 amperes. So this is the output current. Okay, my friends, this is everything for exercise 1. Let's go to exercise 2. Exercise 2. What is the input current of a buck converter with 75% efficiency whose input voltage is 20 volts and is supplying the load with a voltage of 6 volts and a current of 5 amperes? What is the duty cycle? Okay, this is the data of exercise 2. The problem says that the efficiency is 75%. What does it mean? It means that the output power is equal to 75% of the input power. Okay? We want to calculate this first. Okay, PS is going to be equal to 100 divided by 75 times the output power. And the output power is the product between the current and the voltage. The output power is the product between the current and the voltage and the load. And the problem said that the output voltage is 6 volts and the output current is 5 amperes. And we discovered that the input power is 40 watts. With this number, we can calculate the input values. The problem wants us to calculate the input current. The input current is going to be the problem said that the input voltage is 20 volts and the input current is therefore 2 amperes. Now, the second question is to calculate the duty cycle. We know this and we know this. Then the duty cycle is going to be 6 volts divided by 20 volts, which is 30%. Then, this is everything for question 2. The input current is 2 amperes and the duty cycle 30%. Now let's go to exercise 3, the last exercise of this video. An ideal boost converter operates with a 50% duty cycle. Considering that this converter delivers a voltage of 30 volts and a current of 60 amperes to the load, what is the input voltage and current of the converter? Okay, my friends, let's calculate. First of all, we are going to calculate the input voltage. To calculate the input voltage, we are going to use the duty cycle that the exercise provided. VO is equal to Vs times 1 over 1 minus D. And the duty cycle was given as 0.5, of, if you prefer, 50%. Then 30 volts is equal to Vs 1 over 1 minus 0.5. From this it is easy to infer that Vs is equal to 15 volts. Now the catch, when the exercise says that this is an ideal boost converter, the efficiency is 100%. The efficiency is 100%. And what does it mean? It means that when the efficiency is 100%, the input power is equal to the output power. Then okay, and with this data we can calculate the input current. The input current is going to be the output voltage 30 volts, the output current 60 amperes, and the input voltage 15 volts. And then the value of the input current is 120 amperes. Okay, my friends, this is the video that I wanted to make about the buck and the boost converters. I hope you liked it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!